Download this code from codegive.com, link in the description below. Django request aborted, understanding and handling client disconnect ions. The request aborted error in Django is a frustrating but common issue that arises when a client, usually a web browser, disconnects from the server before the server has finished processing the request and sending the response. This can manifest in various ways, from a generic request aborted message in your logs to unexpected errors in your application logic. Let's dive deep into understanding the causes of this error, how Django handles it, and how to implement robust solutions to prevent it or gracefully handle it when it inevitably occurs. 1. Understanding the root cause, client-server communication. To understand request aborted, you need a basic understanding of how HTTP requests and responses work. Client sends request a browser, or any HTTP client, initiates a connection to your Django server and sends a request. This request includes the URL, HTTP method, GET, POST, etc., headers, containing information like user agent, cookies, and potentially data, like form submissions. Server processes request your Django application receives the request, processes it based on your URL patterns and view functions, potentially interacts with your database, and generates a response. Server sends response. Django serializes the data into a suitable format, usually HTML, JSON, or XML, adds HTTP headers, like content type, status code, and sends the response back to the client. Client receives response. The client receives the response, renders it, if it's HTML, or processes the data, if it's JSON or XML. The request aborted error occurs precisely when the client cuts the connection somewhere in the middle of this process, specifically while the server is still working on processing the request or sending the response. 2. Common causes of request aborted errors. Several factors can trigger a client disconnection. User navigation. The user clicks a link to a new page, closes the browser tab, or presses the stop button while a request is still being processed. This is probably the most common reason. Network issues. Intermittent network connectivity, dropped packets, or a sudden loss of internet connection can cause the client to disconnect. Timeouts. The client or server might have configured timeouts. If the server takes too long to respond, example due to slow database queries or complex calculations, the client may decide to close the connection. Similarly, the server could time out waiting for the client to acknowledge the sent data. Server overload. If your server is under heavy load and cannot respond to requests in a timely manner, clients may disconnect out of frustration or due to built-in browser timeouts. Reverse proxy timeouts. If you're using a reverse proxy like Nginx or Apache in front of your Django application server, Gunicorn, UWSGI, etc., the proxy server can also have its own timeout settings. If a request takes longer than the proxy's timeout, the proxy will close the connection to the client, which can manifest as a request aborted error. Client-side errors. A client-side JavaScript error or other browser issue could trigger the premature termination of the connection. 3. Django's handling of disconnect ions. Django doesn't explicitly raise a specific request aborted exception that you can directly catch in your view functions. Instead, the disconnect usually manifests as one of the following. Broken pipe error. This error often arises when you try to write data to a socket, the connection point between the client and server, that has already been closed by the client. This typically happens when your view is trying to send data back to the client after the client has already disconnected. Connection reset error. Similar to broken pipe error, This indicates that the connection was unexpectedly terminated by the client's side. *IO error, or subclass general IO errors can also be indicative of connection problems. *Nothing*. In some cases, especially if the client disconnects early in the request processing, Django might simply log a warning or an error in its internal logs without the error propagating to your view function. This can make debugging more difficult. 4. Code examples: handling disconnect ions gracefully. Here's how you can handle potential disconnect ions within your Django views. Explanation: 1 try, except block. The core logic is wrapped in a try, except block to catch potential broken pipe error, connection reset error and general exception errors. 2 time.sleep. 5. This line is used to simulate a long-running process. In a real application, this could be a complex database query, a computationally intensive task, or an external API call. This helps increase the chances of triggering a client disconnection during testing. 3. Handling broken pipe error and connection reset error. If a broken pipe error or connection reset error occurs, it means the client disconnected while the server was still trying to send data. We log a warning to the server logs, using the logger instance, to record the event. This is very helpful for debugging. We return an HTTP response with a specific status code, 499 client closed request. The HTTP 499 status code is a non-standard status code often used by servers to indicate that the client closed the connection before the server could finish sending the response. You can use a different appropriate HTTP code, like 408 request timeout, but 499 is specifically designed to indicate a client-initiated disconnection. The response body contains a simple message indicating that the client disconnected. 4. Handling other errors. The accept exception as block catches any other unexpected errors that might occur during the processing of the request. This is essential for preventing unhandled exceptions from crashing your application. 5. Logging. Using logging.getLogger __name__ is crucial. Logging the errors allows you to track the frequency and circumstances surrounding these disconnect ions, helping you identify patterns and potential causes. Remember to configure your Django logging settings, in settings.py, to properly capture these logs. Important considerations. Error handling timing. It's important to note that catching broken pipe error or connection reset error is most effective when they occur during the sending of the response, example when using response.write, within a generator or streaming response. If the error happens before the response is being written, the exception might propagate further up the stack. Non-idempotent requests. Pay special attention to handling request aborted when the client might resubmit the request. For example, if you're processing a payment, you don't want to charge the user twice. Use appropriate techniques like generating unique transaction IDs or using idempotent operations to prevent data inconsistencies. Testing. You can simulate client disconnect ions during testing using tools like curl or by intentionally closing browser tabs while a request is in progress. This allows you to verify that your error handling is working correctly. 5. Techniques to prevent request aborted errors. While you can't completely eliminate the possibility of client disconnect ions, here are some strategies to minimize their occurrence. Optimize response times. The faster your server responds, the less likely the client is to disconnect. Focus on optimizing database queries, caching data, and using efficient algorithms. Use streaming responses. For large files or long-running processes, consider using streaming HTTP response in Django. This allows you to send data to the client in chunks, which can help keep the connection alive and reduce the risk of timeouts. Increase timeouts. Carefully, you can adjust timeout settings on your Django server, your web server, example Nginx, and your reverse proxy. However, increasing timeouts too much can lead to resource exhaustion if your server is under heavy load. Test these changes carefully. Implement client-side progress indicators. Provide feedback to the user, example a progress bar, to show that the request is still being processed. This can reduce the likelihood of the user prematurely closing the connection. Use WebSockets for real-time updates. For applications that require continuous communication with the server, example chat applications, real-time dashboards, consider using WebSockets instead of traditional HTTP requests. WebSockets provide a persistent, bidirectional connection, which is less susceptible to disconnect ions. Django Channels provides excellent support for WebSockets. Server monitoring and alerting. Implement robust server monitoring to detect performance bottlenecks, high CPU usage, or other issues that could lead to slow response times. Set up alerts to notify you when problems arise so you can address them promptly. 6. Code example, streaming responses. Here's an example of using streaming HTTP response to send a large file in chunks. In this example, *generate_data is a generator function that yields chunks of data. Streaming HTTP response takes the generator as input. Django will automatically stream the data to the client as it's generated. The content disposition header is used to prompt the user to download the file. 7. Reverse proxy considerations. Nginx example. If you're using Nginx as a reverse proxy, you'll need to configure its timeout settings appropriately. Key settings. *proxy_connect_timeout, timeout for establishing a connection to your Django application server. *proxy_send_timeout, timeout for sending the request to your Django application server. *proxy_read_timeout, timeout for receiving a response from your Django application server. *send_timeout, timeout for sending data from Nginx to the client. Adjust these timeouts to suit your application's needs. Make sure they are longer than the expected maximum processing time of your requests. 8. Summary and best practices. Request aborted errors indicate that the client disconnected before the server finished processing the request and sending the response. Common causes include user navigation, network issues, timeouts, server overload, and reverse proxy settings. Django doesn't raise a specific request aborted exception, but you can catch broken pipe error and connection reset error to handle disconnect ions during response sending. Implement robust error handling with try, except blocks and logging. Use appropriate HTTP status codes, like 499, to indicate client-initiated disconnect ions. Optimize response times, use streaming responses, adjust timeout settings carefully, provide client-side feedback, and consider WebSockets for real-time applications to prevent disconnect ions. Pay special attention to handling non-idempotent requests to prevent data inconsistencies. Test your application thoroughly to ensure that it handles client disconnect ions gracefully. Monitor your server and reverse proxy performance to identify and address potential bottlenecks. By understanding the causes of request aborted errors and implementing the techniques described above, you can significantly improve the reliability and user experience of your Django applications. Remember that a comprehensive approach, including both server-side and client-side considerations, is crucial for mitigating this issue effectively.